everyone, so I'm making this video explanation for you guys today because I know in our this week, week 9's tutorial, we didn't actually end up getting to go through all of the learning objectives. So I know that we kind of got up to the third one here, and for my other class we got through a little bit of the BCNF decomposition, but hopefully, because I know this week's content is kind of tricky and like the tutorial answers are not very good in explaining it, I hope that you guys can appreciate this video, especially now that you've finished your assignment. You can kind of finally look at this content properly and start kind of studying for the final exam. So yeah, hopefully by giving you guys a video, you guys can review it for anything that you're not sure about, confused, and you can like come back and rewatch sections. Okay, so these are the slides for anyone who wasn't here for the week's tutorial, because I know there were a few people who weren't here. So yeah, that's the stuff that we did get through. We kind of finished it off at minimal covers, so we'll go through that today. Alright, so the minimal cover, okay, is basically when you have the smallest set. So let me go into full mode. This is when you have a set that has the least amount of functional dependencies possible for it to actually like cover the entire functional dependency set originally. So what this means is that this will not have any like redundant data in it, and it is like, it cannot be reduced any further because this is the smallest possible set of functional dependencies you can have. So this minimal cover will actually help us with our 3NF decomposition a little bit later on. So the steps are quite simple. All you have to do is, in the first step, you just want to convert everything into something called the canonical form. So what this means is, it just basically means we want to convert all of functional dependencies, so the right hand side of our functional dependency only has one attribute. So I'll show you guys what I mean by that later. And then you also want to make sure that all the functional dependencies with the left hand side has multiple attributes. You want to get rid of those as well, any ones that are redundant. And finally, you want to look at the whole entire functional dependency set and see if there are any that actually are being implied already by other ones, for example using the transitivity inference rule. But yeah, so we're going to go through that. We're going to look at an example. We're looking and going through question 13 of the tutorial questions. Okay, so let me head on over. Just remove this because I did get through that with the other class. Okay, so starting off, these are just the functional dependencies that I've copied and pasted over, and we've got the first 3 steps there just from the slides before. Right, so for this one here, first step, you want to convert the functional dependencies into canonical form. So what that means, remember, is just you want everything, all the functional dependencies, to have only one attribute on the right hand side. So this first one here, it satisfies it. It's already in canonical form. That's great. This one's also in canonical form, and this one's also in canonical form. So we don't actually have to do anything for this step. So everything is already in canonical form for this one. But however, you may come across some questions, for example, where it might have something like, let's say this instead. So if there was a functional dependency that looked like that, what you want to do is you want to change your set so that it becomes, so you want to change your functional dependency this to become AB and AD, right? So just split it up instead of having this one here. Okay, but yeah, this isn't the question, so let's change that back. But yeah, that is what you would do in the case of where there is something that isn't in canonical form. Alright, for the second step, you want to make sure that all the functional dependencies with the left-hand side are multi-attributes. You want to remove them. So we can see that this one's fine, but this one, AB, is made up of 2 attributes. So we want to kind of play around with this one. So what you can actually kind of sense in this is that having the whole AB gives us D is not actually relevant. It's not necessary, because if you have a think about BA, right, so this functional dependency here, if you start off looking at that, because of the rule of reflexivity, obviously B can get itself, right? So that's one of the Armstrong's rule. Reflexivity? Am I spelling that right? Reflexivity. Okay, I may be spelling this wrong, but you know, here's the slide anyways for you guys if you want to reference that. Reflexivity. There we go. I love that. I'm definitely illiterate. And yeah, let's go back to the steps there. Okay, so yeah, that is the first thing that we can infer from this first functional dependency. Easy, right? And you should already kind of see something similar, because there is this AB here. What you will actually realize is there's also an AB here. So because of that last functional dependency, it says that AB gives us D. Okay. Now, if you think back to your transitivity rule, you'll see that based on the ones that we've kind of just come up with, so B gives us AB, and then because of this functional dependency, AB also gives us D. So this is because of the transitivity rule, okay? And so yeah, you'll realize that this AB here in the middle is not actually necessary. Because of this rule, we can just reduce all this to BD. So what I mean by that now is that the new functional dependency set can just become, we can remove this AB gives us D and just replace it simply with a B gives us D. And that's it, right? So just to review, why were we able to remove this original one and give us this? Reason was because if you actually just look at B and use reflexivity rule, you'll see that B gives us AB, and in turn, AB simply gives us D based on that original one there. So because of that, you can straight up just infer that B gives us D from the transitivity rule. And that's why you can remove that one and leave you with just this, right? So you basically just remove that A there. Okay, so moving on to the next step. So step 3 is finally you want to look at this entire thing and see if there's anything you can remove. Once again, this one here will be using your transitivity rule, because you can kind of see that BA, right? BD, okay, so B gives you D in this case, and then you see that D also gives us A, right? But you've got this B gives you A as well. So what this basically means, from these two, you can use a transitivity rule, and you can say that B gives you D, D gives you A. Transitivity. Am I spelling this wrong? Yes, I am. Transitivity. Spelling is hard. But yeah, so you can tell from this that BD gives you B gives you D, D gives you A. So actually, straight up, you can just say, infer from that B gives you A. So this is actually redundant, right? And therefore, your new one, because it's basically redundant, because BA is inferred from these two, right? From these two. All right, so daisies is inferred from there. So therefore, your final minimal cover is going to be all this except for your BA, and you're left behind with D gives you A, B gives you D. So that's your final answer, right? That is your final answer. Final minimal cover is this. Alright, if there are any questions, please do let me know. Ask me, you can email me, or ask on the forums for any help. Alright, wonderful. So let me just zoom out. So if you need, take a screenshot or whatever to try and understand that. Alright, moving on to the minimal cover slides. So yeah, that was the 3 steps there. It is a good idea to memorize that for your exams. But yeah, let's move on to the next learning objective. So this is the last and final learning objective, and I'll say that this learning objective is probably the hardest one out of all of them, since it does rely on all your knowledge from previously. And this is why I wanted to make that video, because it is a hard concept, so having a video where you can come back and rewatch sections can be helpful. Alright, so the first one here is your 3NF decomposition. Remember from our normal forms slide before, we said that we're only in this course, we're only going to learn about the industry acceptable normal forms, so BCNF and 3NF. Therefore, those are the only ones that we have to learn how to decompose. So the first one is 3NF decomposition. This one is the easier of the two, and you can see here are the steps, right? It's quite simple. However, it does build on our previous learning objective, which was minimal covers. So basically, you start off by making a minimal cover, and then you want to flatten them all into relations. So simply all that means by flattening is this original set will just become this. So you remove the arrows between each of these functional dependencies. Easy. And then the second step here is saying that if your final set has no relation that has a candidate key, then you want to add a candidate key to the set. So I'll show you guys what I mean in a question, right? So we'll go to this question here. So this is question 7 of the tutorial questions, and we are looking at question B. All right, so I've already prepared something here. I've just copied and over the steps from our slides, right? And we're looking at this simple set here. So this is quite simple, because if you just go through like step 1, find the minimal cover by what we learnt before. If you just go back and review these steps, first convert all of the functional dependencies into a canonical form, meaning all the right hand sides should just have one attribute, and they already do. So we can skip step 1. For left hand side, for step 2, for left hand side that are multi-attribute, we don't actually see any there that have more than one, so we can skip step 2 as well, and then remove any redundant. This one's a very simple cover, so B, C, D gives us A. There's no really like transitivity there or anything, so this is your minimal cover, right? You keep it as this, okay? Minimal cover, that's it. All right, so you don't actually have to change anything for this question, and that is your step 1 done. Okay, so step 2, we need to flatten the minimal cover. So simply what that means is you want to have these arrows removed. So you'll just have BC, and this one here will become DA. Very simple. We've just flattened it so it becomes a relation. Step 3, ensure that the resulting set has a candidate key, and then add one if it doesn't already. So let's just have a look at these, right? So remember, candidate keys, revision from our tutorial, is candidate keys are able to get you all the other attributes in the functional, in your schema, right? So they're looking at the functional dependencies as well. The schema here is A, B, C, D, right? So if we just look at this one here, is this a candidate key? Well, BC, from B, we can get C already, so it's not really necessary to have C there. But we're not able to get D or A at all with just these two, right? So that's not a candidate key. How about DA, right? So D gives us A, but we're not able to get B or C from D or A. So it's also not a candidate key. So we do have to look for a candidate key. And luckily for this one here, it's quite easy because we've only got so little functional dependencies. We want to think about Well, we want to get C, we want to get A because they're on the right hand side. So we need to get these two, B and D, added into our candidate key, right? So that's your candidate key. And so it says add 1 if it doesn't exist. So that just means that to our already flattened minimal cover, you'll just want to add the BD. And that's it, right? So your final one, final decomposition is just this, and it's quite simple. It's just the BC, DA, and the BD. All right, cool. That's literally it. So 3NF is much, much easier, I will say that. But you'll see on our next slide, right, BCNF is a bit more difficult. So one of the classes I did get through BCNF with, but I will cover this question again, and you can see these are all the steps. Let's get rid of that, and I will go through this with you guys. So a couple of things about BCNF decomposition is that it's non-deterministic, right? So non-deterministic, and I want to stress this because I remember when I was doing the course, I didn't know this, and I would think that my answer would have to be the exact same as the answer in the tutorial answers. However, BCNF decomposition is non-deterministic, meaning that it is random, right? You'll see as we go through the process that when you're looking at each relation and you're breaking it down further, you are choosing a random relation in a random order. So it can generate multiple different answers. That's what non-deterministic means, right? So your answer may not always be the same to the tutorial answers. So if you really want to check while you're studying for your final exam, you can ask in the forums and a tutor can help you figure out whether your answer is correct. So yeah, that's a key thing I want to stress. But here are the steps. They look way complicated than they need to be. So I'll just show you guys an example and walk you through it. We'll refer back to the slides if need be. So just a revision, for your BCNF decomposition, you will actually need to keep in mind the BCNF rules. So what makes a functional dependency BCNF, right? So the first one here is rare. You won't see it as often as I said in the tutorial, but this one here you will be using a lot, right? So we'll be referring to that. So yeah, we're looking at this question here. Once again, we're going to question 7, but we're going to question E. All right, cool. So moving on to this, first step is you want to have just an understanding of the schema first off, right? Just starting off, the schema is everything that is in our functional dependencies. So we've got A, B, we've got C, and we've got D. So we just want to keep that in mind. Right, so we'll basically be having multiple passes, or we'll kind of be going through like multiple sweeps of our functional dependencies. So the first pass, I'll call it this, right, is going to consist of this as our schema set, right? So currently at this stage, our schema is A, B, C, D, as we've just started, okay? And then for each of these passes, you want to be looking for the relevant functional dependencies at this stage. So because we're just initially starting, all of these are relevant. And what it means by relevant is you want to only include really the functional dependencies that have attributes that are actually in your schema at the current point. So I'll show you what that means a little bit later as well. But right now, of course, we haven't removed anything, so these are all relevant. Now, you're going to go through, similarly to how you figure out whether a schema is in BCNF, you're going to look through each functional dependency. So starting from the left, right, you will check is AB gives us C, B in BCNF, right? So if you just check AB is able to get you C, that's good, and AB is also able to give you D. And that makes up the entire schema. So is in BCNF because of our second rule there. The left-hand side is a super key. It's able to get all the other attributes in our schema. Now, moving on to the next one, we'll basically be keep looking through the relevant functional dependencies until we find a functional dependency that is not in BCNF. So looking at this next one, AB gives us D. We already know AB also gives us C, so it's also in BCNF because of our second rule. That's an easy one because it's very similar. Okay, how about this next one? So C gives us A, and that's it. C gives us A, and then we've got A now, but A without B isn't able to give us anything. So it's not in BCNF, and therefore you want to fix this functional dependency. Not really fix, but what we're going to do is we're going to generate a new schema set now that's going to consist originally of your first original schema, and then we're going to, and it's here in this step here, what we're going to basically do is we're going to replace the schema now with the functional dependency, sorry, the schema itself, the original schema, minus the right-hand side of this not in BCNF functional dependency. And we also want to generate another set that is just the left-hand side plus the right-hand side of our functional dependency. So what I mean by that is that now our new schema set is going to be the original schema minus the right-hand side of our not in BCNF functional dependency. So it's going to look like this. And then based on this rule here, we also want to get a new schema with the left-hand side plus the right-hand side. So this left plus this right. So that's C plus A. Right, and that's it. Okay, so that's it of your schema set. And if I just translate this over, this just basically means that this is now BCD, you've removed the A, and this one is just CA. So that's your schema set now. Right, so you'll see what I mean by this because it is non-deterministic, since every time you are going through your relevant functional dependencies, you could go in a different order and you could break down like this one first before this one, and then that generates something that will look different as you continue and continue. So it is random, and that's why it's non-deterministic. You won't always get the same answer. Alright, so moving on, we're going to have our second pass now, and our second pass is going to consist of this set that we now have at this current state. So the schema has changed a little bit because we are just looking at BCD now. So we're looking at the first schema in our set. Alright, so once again, right, this is non-deterministic because you could look at this one first and this could change your answer quite a bit. But we're just going to go from left to right. So we're going to look at the schema BCD first. Now the next step is we're going to look at the relevant functional dependencies. And what this means is we are going to be looking for all the functional dependencies that are relevant to our actual schema. So what you'll see is this one here, this first functional dependency says AB gives us C, but we don't have an A, so we can't actually use this functional dependency anymore. So we just straight up remove it. And moving on to the next one, this one also has an A, but we don't have an A, and there's no other way for us to get D without A, even though we have B. So you want to get rid of this as well. Okay, and then moving on to that, you'll see here, actually, yeah. So you'll see here now that CA, you also don't have because we don't have the A. So you're actually only left with D gives us B at the very end. Okay, well, we'll go through each of these functional dependencies. This one here, D gives us B, but it doesn't give us C. So this is not in BCNF. So you want to break this DB, this D gives us B functional dependency, and give us a new schema set, right? So you'll have, like the rule before, you'll have itself minus the right-hand side. So we have this schema here, itself, minus the right hand side of our not in BCNF decomposition, not in BCNF functional dependency, right? So remove B, and then we add D and left hand side plus right hand side, so D plus B. So that gives us finally CD and DB. Cool. All right, moving on then. Oh, and one more thing, don't forget this, I nearly forgot. Even though, yes, you are modifying, you've just broken down this one though, you've just broken down BCD. So you want to make sure that CA is still included because we haven't looked at this CA yet, right? So you want to include that still in your current schema set. All right, so third pass, you'll see that this kind of just goes further. It's kind of like a tree. You look at one BCD, you break it down, and now it generates these two. Then you want to look at this one, etc., etc. So our new, so our new set is going to be CD, DB, and CA, right? So we'll just look at these ones. It's a random order, but we'll just look from left to right. We'll look at the first schema in the set, which is CD. So relevant FDs, let's have a look. So we started off with these. So let's just look through all these and see what we can remove, what we can keep. So this one here has A and it has B. We definitely cannot use this one. We don't have that in our schema. This one also we don't have. This one here, C, we don't have an A, so we don't really need this. And D, B, nothing, right? Because we don't have a D or, we don't have a B. So there's actually no relevant FDs for this one. And that's fine, right? That's a good sign because it looks like we're nearly finishing. So, like we're nearly finishing this entire decomposition. So we say, yeah, CD is in BCNF, basically, because obviously the schema is only CD. CD can get itself. So it is in BCNF. We're in rule 2. Yeah, so there we go. That's the first one. And because it's fine and in BCNF, we don't actually have to create a new schema set. We don't have to be breaking up anything. So we can continue on and look at the rest of our set of schemas. So we can look at DB now and have a think about relevant FDs. So I'm going to copy and paste from the original here. DB, right, so we don't have an A, we don't have a C, we don't have an A, can't use that one, no C, no A. We can use this one, so it's not entirely no relevant FDs, but also just from this, this is in BCNF, right, because these are like the only two attributes. And yes, they get you the entire schema, the thing we're looking at, which is just DB. So yeah, DB is in BCNF. Cool. So I was actually meant to do, sorry, CD is in BCNF. There we go, typo. All right, looking at our final one, and because we haven't hit any where we had to actually break it down further, we can move on to our next schema and look at schema CA. So very, very finally, let's just quickly do this and see. So we've got the original functional dependencies. CA, we can't use this one because we don't have a B. Can't use this one, we don't have a B, we don't have a D. We can use this one, that's good. And this one, we can't use either. Oops, sorry, yeah, there was a typo here. Because there was no relevant FDs, you just say that the entire CD is in BCNF and you don't have to do anything with that. Yeah, so that was actually correct. So yeah, we look at this now and we say, okay, CA, obviously, C gives us A, it's the entire schema now. So it is in BCNF as well because of rule 2. Same rule here. And that leaves you with all the schemas that we've looked at, right? So that's a good sign. Once everything is in BCNF, that means that our decomposition can actually finish. So what this says is that, therefore, your CD, right, your DB, and your CA are all BCNF. That's great. Therefore, your final decomposition is these three. And that's your final answer, right? So that's your final answer there. For this one, because it's not as complicated, there's only so many few answers that you can generate. And this one should be similar to your tutorial answers. Cool. That's it of BCNF decomposition. I hope this has helped. If there's any questions, please do ask me on email. And yeah, good luck, and I'll see you guys next time. Bye bye.